All right. Hello, everyone. My name is Joseph, and I will be the instructor, and I will be going over Java Set 1. So let's get started. Question 1. If a variable is declared as type int, it can only store integer values. For example, it can store only whole numbers in the range of this extremely low number to this high number. Should an arithmetic operation yield a result of type double, then it is not normally possible to store this result in a variable of type int. However, typecasting allows the user to alter the variable type to operate with different variable types. Narrowing typecasting is converting from a variable type of larger size to a variable type of smaller size. From the options below, identify the code snippet with narrowing typecasting that is both syntactically and logically correct. Okay, so there's a few things going on here. And first, let's just go over a few key concepts here. So biggest one is the concept of typecasting. And in short, typecasting is something we can do in Java that allows us to convert between different primitive types. So for example, if we want to convert integer to double, then we can use typecasting. And similarly, right, we can also do the reverse, double to int. Now, one thing to keep in mind is there is narrowing typecasting and widening. And narrowing is typecasting from a larger size, such as double, to integer. And the reason it's called narrowing is because we're kind of reducing the size and contents of that variable into integer. And in this case, with the double, a double, unlike integers, doubles contain decimals. They contain a higher level of precision. So typically, when you do narrow typecasting, you typically lose some level of precision. Like for example, 6.3 into an integer will just yield 6 because we chop off the decimal. This is not really a problem when we go integer to double because a double is it's a more precise version of the integer, so we typically don't really lose precision like this case. So like integer 6 would just become 6.0 and that will be known as widening. In this case, looks like the code is doing narrowing typecasting, and we want to identify which of these is syntactically and logically correct. So let's go over these and then see what the answer could be. So option A, we have public static void main, string args, and we declare an integer b, double x equals 8, y equals 5. So we have two doubles, and now we want to assign b to int x divided by y. And this so far is looking correct. With typecasting, you typically, the notation to do this is to add the variable type that you want to assign in front of the operation on the right side. And looks like this is doing that correctly. So let's go down to B. Int B, all the same, double x equals 8, y equals 5. B equals x divided by y. So it looks like they don't add the int here, and rather they put it into the last statement of the print statement. So this is wrong because we are without the int in front of the x and y, the compiler will complain, saying that we are essentially trying to convert a double to integer without typecasting, and the compiler is going to complain and it'll throw an error. So B is incorrect. Now let's look at C. All the same, and looks like they add a double on the left-hand side of the declaration of B. And again, this is not the syntax that Java uses to typecast. The typecast will have to occur on the right side here. So yep, C would be wrong as well. So that leaves A as our final answer. Okay, moving on to 2. One of the primitive data types used in Java is the Boolean type. Boolean is a binary logic data type that returns the result of comparisons between 2 quantities. For the code given below, select the correct output from the options. Okay. So this will be a question. Looks like we will be evaluating some Booleans. And real quick, right before we start, let's one key concept that will be useful, and that is a syntax that Java uses with Boolean expressions. Now, normally we're used to just seeing if, let's say like bool is a variable, right? So if bool equals true, then we evaluate whatever is inside here. So in Java, we are actually able to, as a shorthand, we don't even need this. And this will basically be logically the exact same as the previous statement. Java allows us to shorten things for readability. So just keep that in mind. If there is no equals equals true for Boolean statement, then that is essentially the same thing as just writing it by itself. So with that in mind, let's look at the code here. So we have Boolean variable 1 equals true, variable 2 equals false, x equals 3, y equals 4. While variable 1, x equals y. So variable 1 is true. So we're going to enter this while. If x equals y, which is not true, x is 3, y is 4. So we're going to enter this else. And we're going to print out variable 1, which is true. And with Booleans, if you print a Boolean, it just prints out, the respective value. So it'll print out true. Oops. So let's write down the output here. So we will print out true first. Fine. And now we set x equal to y. So now x equals 4, y equals 4. So let's keep that in mind now. Circling back to the while statement, while variable 1, which is still true. But now we set x equal to y. So now this if statement will hit. And we will print out variable 2, which is false. And now we are setting variable 1 equal to not x equals y. Now, if you remember when I said in the beginning that in Java, if you just a simple Boolean statement inside an expression, without the equals true, that is pretty much behind the scenes the same thing as just writing it by itself. So x equals y is pretty much the same thing as saying if x equals y, true. Now it's a little ugly if you write it that way, but that is essentially the same thing. So is x equal to y? Yes, it is. They are both 4. So the statement now becomes variable 1 equals not. So this was true. And not true flips that. So equals false. So variable 1 equals false now. And now with that in mind, we exit the while loop because we circle back, variable 1 is false. So the final print statement will be true false, which is B. Okay, moving on. In any given Java program, each statement has to be terminated by a semicolon. However, the given code is a method of printing a line without using any semicolons. Fill in the missing code so that the correct output is obtained. The line no semicolon is printed. Okay, so this question is a little tricky for several reasons, and I will explain why. So first and foremost, we need to understand that let's take a look into the printf statement, because we want to see what kind of expression and what kind of evaluation this is. So this is just something you can just look up or just know in general, but basically system out printf returns a type of print stream. So if you look at the Java docs here, That print statement, while it does print to the console, the return type is behind the scenes this type print stream, which is a Java object. Now, we don't really need to know right now what exactly this does or how it works, but the point is this statement right here, system.out.printf, it returns a Java object, basically, right? So with that in mind, objects, as we know, they can either be null or not null. But Java objects cannot be true or false, right? That's only for Booleans. So in terms of the syntax here, the correct answer here would be A. And the reason is because B checks if the output, if the return of printf equals true, and that is, that'll be a compiler issue because again, we're not looking if things are true and false, we're looking at an object, right? And objects can only be either null or not null. So if we can rewrite the whole if statement actually here and say system.out.printf no semicolon equals null, and then here. So this is the full thing, and this will the compiler will be okay with this because again, this is just returning an object, and we can check if objects are null or not null. But B and C are checking if they are true and false, which is not a correct check. And another thing that really important concept to keep in mind is in Java, when we evaluate if statements, in checking the if statement, it does execute whatever is inside. So while if you think about you can kind of think of it like it's almost it's executing two things at once, right? It is checking for the validity of the statement. And two, while it's doing so, it executes this at the same time. So it executes this printf. Now, if you wanted to like go a little bit deeper into this, it will print out this because it executes this. However, whatever happens inside this curly brace will not occur because the return type of printf no semicolon is not a null. It'll be, again, type print stream, and that is its own object. But yeah, it's a little bit deeper here, but basically what we need to get from this is conditionals check, if you want to evaluate if you want to have code that, works with the compiler, checking if it's null only works with objects, and with objects, you cannot check if it's true or false. So yeah, that was a bit a lot, but those are really good and key concepts that are at play here. So without all that in mind, the answer is A. All right, let's move on. Number 4, for the options given below, which one will execute without any errors? Okay, so again, a few things to keep in mind here is the difference between strings and chars. So as you might have seen already, we can have a string and we write it just using double quotations. On the other hand, chars are smaller versions of strings and they are written using single quotes. And in addition to that, their chars are only allowed to be one character, while strings can be one or more characters. So those are the rules that we need to keep in mind looking at these questions. So A, string EG equals example, system printout EG, and example is written using single quotes. That is wrong because, again, single quotes are for chars, and this is going to hit some compilation issue. Let's look at B. Char EG equals example. So it's the same thing as A, but we declare EG as a char rather than a string. And again, we might think that this might work because we're using char and single in single quotes, but remember chars are only allowed to be one character. So this again would hit a compilation error. All right, let's look at C. String EG equals example with double quotes. Print out the EG. So this is looking fine to me. We're declaring a string and we're using double quotations to write that string. So this looks pretty right to me. Let's look at D. Char EG equals example. And again, so remember char is only limited to one character. And on top of that, it has to be in single quotes. So this is completely wrong. So that leaves C as our final answer. All right. Number 5, while printing more than one thing, it is important to either print them with spaces in between or in 2 different lines for clarity. The 2 variables C and D are declared as type double, and they have been used to illustrate the difference between typecasting and no typecasting. From the code snippets given below, select the one that will correctly print the values of C and D respectively, with a gap of a single space between them. So the important concept, let's keep in mind for this one is when we use systemout.print in Java, systemout.print, when we print out, like if we want to print out multiple variables within the same statement, we want to concatenate it using the plus sign. So for example, if I have variables A and B, we would do A plus, and then we can add some sort of empty string or space, and then plus B. So this is typically the notation to print out variables in a print statement. And yeah, let's look into these questions here. So looking at A, x equals 6, y equals 5. Double C equals double x divided by y. So this is correctly typecasting. It's converting the output of x over y and converting that into a double. And now we have double x divided by y and system print out. Okay, so just looking at the last line, we can tell that this will not compile because in a print statement, if you want to combine the printing variables, we don't use the commas. We use the plus to concatenate these outputs. So this is incorrect. And looking at B, we have the same thing. It looks like everything is the same. In the print statement, we have single quotes rather than double quotes. And again, for the same reason, this is incorrect because we're not using the plus, we're using the commas, which is incorrect way to print stuff. C, we print out C plus double quotes and then plus D. And that is all syntactically correct according to the rules. So, but let's look at the last one here. So we have all the same, and then we print out C using the plus, that's correct. We added the space, but this time we used a single quotes plus D. Now, this is a little tricky because on initial glance, we might think that this is going to print out the same thing as C. But there's one key concept that we have to keep in mind, and that is chars are, when we want to print out chars, the print value of what gets printed out is actually the ASCII value of that char. And if you haven't heard of that, right, if you just look up ASCII table, go to asciitable.com, you can see there's an entire table of respective values for each possible character on the keyboard. So going back to the question, right, if we, in this middle statement with this blank space, because that is represented using a char, when we try to print that out, it will not print out that char, it will actually print out the ASCII table representation of that char. So since that's a space, right, let's look at the space. This is 32. So While we like it does look correct, what this will actually print out is a 32, not a space, and that's not what we want. So for that reason, D is incorrect, and that leaves C as our final answer. All right, moving on to 6, select the correct output from the options given below for the following Java code. So this is, looks like we will just be evaluating a large Boolean expression. And just to recap from what I mentioned earlier, right? If you have a like if, you know, Boolean, like if bool, that is syntactically and logically the same, it's accomplishing the same thing as saying if bool equals true. And similar on the opposite sense, if not operator, that is the exact same thing as saying if bool equals false. And it's just like a more, I guess, a more concise or more readable version of the top one. So with that in mind, let's look at this. So we have 3 Booleans all set to true. And it looks like we just want to determine which, if it's going to enter the if or else. So this is a really long, ugly expression. So what I like to do is let's rewrite it and let's try to evaluate it little by little and split it up and, you know, do little by little. So bool 1 or bool 2 and not bool 3 or not bool 1. Okay, so this is the expression we have. So what I like to do is maybe split these up, you know, make it a little bit more readable, right? So it looks like this entire thing is surrounded by this knot. So we can kind of, you know, shift that over a bit. We'll deal with that later. And similarly, the same thing. So it looks like we have this or, and then this entire thing. So let's kind of partition that out. And now within here, we have this and this or this. So let's go a level deeper and section that out. So let's start at the deepest level, which will be this expression, and then let's work our way up. So bool 1 and bool 2. Now remember, both of these are true. So true and true is true. Now we can see this is not true, so false. All right, and now we have this or this. So bool 2 is true, remember, and not bool 3 is not true, so false. So we have true and false or false. Now true and false is false because both of these have to be true for that to be true. So that's false. All right, looking better now. So we can evaluate this one now. So false or false is false. So we can kind of bring this in a bit more now. Not bool 1, so that is equal to not true, so false. And now false or false, that is false. Now look at this. Now all we have is not false, which is true. So this will be true. It'll enter the first if, and we'll print out if statement executed. So answer for that is A. All right, number 7. In Java, we have 2 special keywords to create special variables or methods, static and final. In the code given below, each line has been numbered. Identify which of the following lines of code are incorrect by selecting the correct combination of line numbers from the given options. Okay, so let's review quickly what static and final keywords are, because these are really important to know. So in Java, a static keyword is used to, or in the sense, if we're looking at variables, a static variable is a variable that is used there is only one instance of it within the entire class. And what I mean by that is, if we have a class, let's say like person, right? If I declare a static variable within that, we can say if we have a variable called public static occupation, this variable is shared across all instances of that class person. And there will only be one instance of this, right? You can't create multiple versions of this variable. So static it's also called known as a class variable, and it is a variable that's shared among all instances of that class. And let's look at, so we have also final. And a final variable is a variable that cannot be modified. So anything that you want to declare and you don't want to ever modify or change, then you want to declare that final. So for example, final int, let's say height equals 12, right? So if at any point in the future, anyone wants to try to modify height, it'll give an error. It'll complain saying, no, this is final, you cannot change it. So that is static and final. Very, a commonly used and important variable types in Java. So let's look at the question. We have public static void main, static int a1 equals 10. All right, so static variables, one important thing to note is they are always declared at the top of the class, not within the method. So because of that reason, 3 is going to spit out an error. So let's just highlight 3 with that in mind. So this is wrong. If this were declared, let's say like above this main, then that would be correct. Okay, so we have final int a2 equals 20. So this is fine. Unlike static variables, we are allowed to declare final variables within a method. So we're declaring a2 and setting it to 20. Line 5, a2 equals a2 times 10. Now I see another problem here. And again, like I said before, final variables are variables that we don't want to modify. And line 5 here is trying to modify a2. So that's wrong. So, and then we have line 6, print out a2, and that's looking fine to me. So with that in mind, 3 and 5 are incorrect. So B is the answer. All right, number 8, in the given code snippet, execution will not take place because of an error in the declaration of the integer variable a1. Identify the type of error by selecting the correct answer from the given options. All right, so looks like a quick recap on what private variables are. So typically when we want to make, class like public class dog, private variables are variables that are only able to be accessed within the class. They're typically initialized and declared above the class, above all the methods. And private variables are variables, again, are specific to that class and can only be accessed within the class unless, and within the class, you can have these like getter methods to access this. So public int get a1, right? And this allows outside classes to access that private. But what's important to know is that these are variables that are kind of hidden away and are variables used to describe the attributes of this class. So as we can see here, let's go over these possible errors. A says unexpected literal, and yeah, not really. I mean, it's all we're doing is just declaring a variable and printing it out. Nothing to do with any unexpected literals. So that doesn't seem right. Possible loss of precision. So we get this when we typecast incorrectly, and there's no typecasting going on here, so it's not going to be any loss of precisions. Unreachable statement. Not really. I mean, both of these are reached. Typically, the only way to get unreachable statements is if you write code outside after a return statement. So let's say like public int foo, right? Return 1, and then you want to like say system out.print hello. So this will return a unreachable because we are trying to print statement after a return, so that this line will never be hit. So that's not really happening here. So it's not going to be C, which leaves D as the final answer, illegal star of expression. And that is happening here because we are trying to declare a private variable within a method, which is not allowed in Java. You can only declare these outside the method. So D. All right, number 9, different variable types have different memory sizes. In the program given below, 3 different variables are declared to store the sizes of int, double, and byte. Find the output of the program. Okay, so this knowing how to solve this kind of comes down to what, if you know what the integer, double, and byte sizes are within Java. And this is not only just a Java thing, this is a general knowledge within any type of computer and how they store data. So we can recap a little bit here. So when we want to store integers, they are stored in 32 bytes. And the reason is because if you look at the actual numbers, like the caps of the integer, it is 2 to that number. So 2 to 32, that's for integer. And then for double, this will be 2 to the 64. 64 is the number of bytes. So 2 to the 64 is the number of possible values of that double. And then byte is 8, which is 2 to the 8 possible values of that byte. So again, this is just kind of a general knowledge that you should be aware of. And if you calling integer.size returns the number of bytes of that size. So size int will return 32, size double is 64, and size byte is 8. So with all that in mind, the problem becomes just a simple math question. We can plug these values in. So 32 plus 64 divided by, and then size byte is 8 times size int, which is 32. So once you evaluate this, you will get C, 0.375. All right, moving on to the last question here. For the given code, select the correct output from the given options. So we have a byte variable counter, set it equal to 1, int I, for I equals 1, I is less than 25, I equals I plus 5. We increment the counter by multiplying it by the current value of I and then printing out that counter. Okay, so upon first glance, this does just look like a normal for loop that just kind of cycles through 5 at a time up until 25 and printing out that value. But the one important thing is this right here. So the counter is a byte. And if you remember from the last question, bytes are 2 to the 8. The size is 2 to the 8. And so if you evaluate that, so that's 256 possible. So the size of a single byte is limited to 256. And because everything in Java is has a both positive and negative value, the value of a byte is limited to only 128 to 127. And anything over that will essentially just kind of loop back around to the negative. And that's something that we don't want ever when it comes down to any sort of calculations. So and Java does recognize this. And so if you look at this line right here, counter equals counter times I, we are multiplying counter, which is a byte, times I, which is an integer. So we're multiplying something that can hold only 2 to the 8 values, right, by something that can hold 2 to the 32, which is a massive number. And because of that, Java will complain. There will be a loss, a major loss of precision there. So this will end up being a compiler issue, which is going to be D. And if just to dive a little deeper into this, right? If we, so like there could be one good way to look at why this is one possible fix to this is to typecast this into byte, right? And this will kind of initially fix that Java, the complaining issue where Java will be like, oh, this is dangerous. This will lead to, like it'll lead to like data precision loss, and it's not allowed. We could convert it to a byte, but the problem with that is the values that we hit within the for loop will eventually exceed the value of 127, right? We have 1 and then 1 times 1 and then times 6 because we add 5 and then times 11, right? So eventually we're going to hit way above 127, and what will end up happening is the counter will end up exceeding 127 and then looping back down to the negative 128, and it'll kind of cycle through this really narrow range of possible numbers. And it's not going to get the desired output of what we want, which is kind of just printing out the full counter list. So yeah, this is just a little lesson on bytes and integers and the differences on them, and like why we use some over others. But yeah, so with all that in mind, the output, it won't run, it'll hit a compiler issue, and the answer is D, none of the above.